Okay, so what we've learned so far in this unit is we learned how to write the equation of a circle when given the center and the radius. We learned how to change the equation of a circle from general to standard form so that we could identify the center and the radius. And then we learned how to write the equation of parabolas, both with vertical directrix and horizontal directrix. Today we're going to start learning how to write the equation of an ellipse. Okay? Now, an ellipse is basically a stretched out circle. Okay? It's a conic section which is basically a stretched circle. An ellipse has a center, just like a circle does. Okay? Now, another thing that we've talked a little bit about with parabolas was a focus. With an ellipse, you have two of those. The plural form of that is the word foci. Okay, let me say that again. You know how when we had parabolas, they had a focus and the parabola opened towards the focus? With an ellipse, there's two of them. They're equal distance from the center, like that's the same distance as that is. But when you say, you don't say focuses, you say foci. Okay? Within an ellipse, you have a major axis and a minor axis. For this particular ellipse, since it's on its side, it's longer than it is tall, the x-axis is the major axis and the y-axis is the minor. There are two different equations for ellipses, a horizontal equation and a vertical equation. Now, those equations are very, very similar. The only difference is with a horizontal ellipse, A goes under the x, B goes under the y. With a vertical ellipse, one that goes up and down, it's taller than it is wide, B will go under the x, A will go under the y. Now, I know that sounds like a lot to remember right now, but you will be given the formulas, and it'll just start to kind of come together once you work them out, okay? One thing you need to remember is your A value will always be larger than your B value. To find the foci, the focus on each side of the center, this is the equation, okay? So I know it seems overwhelming right now. That looks like a lot of foreign language to y'all, but once we start working them out, it'll start to come together for you. Okay, so turn to page 12 and let's try one. Okay, so in the picture we have an ellipse, okay, a stretched out circle. My bad, 17. I don't know where I got that. Sorry, 17. So in that picture, in example 1, we have an ellipse. Is it a horizontal or vertical ellipse? Horizontal. Isn't it longer than it is tall? That's known as a horizontal ellipse. Okay? Anytime you have a horizontal ellipse, isn't the length within the x-axis longer than the length of the y-axis within the ellipse? So with a horizontal ellipse, the x-axis is always the major axis. And that would mean the minor axis for this one is the y-axis. Hold on and I'll scoot it up. Okay, anytime you have a horizontal ellipse, which is an ellipse that's like more sideways, more wide than it is tall, the major axis is the x-axis. Because within the ellipse, isn't that a lot longer than that is? So that's why the x is the major axis, the y is the minor axis. Now, how long is the major axis? From this point to this point, how many units is that? 16. Okay, because it goes from -8 to +8, which is 16 total units. How long is the minor axis? 10 units. It goes from 5 to -5, which is a total of 10 units. Okay, now we are going to identify the A and the B. From the center to the side is how many units? No, just from the center to one side is 8 units. From the center to the top is how many units? 5. Remember on the previous page I said A is always greater than B? So, now that we know our two values are 8 and 5, which one's the bigger one? 8, so A equals 8, B equals 5. Yes? Okay, so now that we have the A and the B, we're able to write our equation of this ellipse. Since it's horizontal, you're going to be using this one. X squared plus y squared equals 1, and then over A squared and over B squared. Okay, well just kind of use your common sense. If this is X, under it needs to be the number that's on the x-axis, and isn't that number 8? So 8 squared, because you have to square it, is 64. And if this is y, you need to look at the y-axis, 5. And if you square that, you get 25. And so that is the equation of that ellipse. X squared over 64 plus y squared over 25 equals 1. You mean like x minus h, y minus k? Is that what you're talking about? That's just the equation, kind of like the equation of a circle equals 1. An ellipse is just a stretched out circle, so it equals 1. I don't know if this is what you're asking, DeAndre, but like with a circle and a parabola, we always had x minus h squared, y minus k squared. Well, think about what the h and k would be. Wouldn't they both be zeros because the center of this ellipse is at 0, 0? So that's why there's no number with it. Tomorrow we will learn about ellipses that have been moved and their center is no longer the origin, and they will have a number for h and a number for k right here. Okay, before we learn about foci, let's go down to the second example and try all this again before I throw in something else. Okay, so let's look at example 2. Is that a vertical or horizontal ellipse? Vertical, because it's taller than it is wide. Which axis is the major axis? This time, look, the y-axis is the major one, right? Because isn't that a lot longer than this one is? So the major axis is the y-axis. And how many units is it? How many total units is it? 10. That would mean that the minor axis is the x-axis. And how many units is it? 4. Okay, now we need to identify A and B. And what do you know about A and B's relationship? Well, no, what's their relationship to each other? A is always greater than B. So, first let's find the center to the side. How many units is that? 2. And then from the center up is how many units? So A will equal and B will equal 2. Because A is always larger. Now let's write the equation. It's always x squared plus y squared equals 1. And then you really don't even have to remember if A goes here or B goes here. Use your common sense. If this is x, don't we need to focus on the number on the x-axis, which is 2, and square it, which will give you 4? And then if this is y, don't we need to look at the number on the y-axis, which is 5, and when we square it, we get 25. So there's your equation of that ellipse. Any questions so far? Okay, now let's talk about foci. Remember, foci, what? That's part of the equation of the ellipse. Okay, the equation for foci is c squared equals a squared minus b squared. So I'm going to write that. C squared equals a squared minus b squared. Well, don't we already know what a and b are? So we can fill them in. C squared equals a squared, which would be 8 squared, minus b squared, which would be 5 squared. And then that becomes c squared equals 64 minus 25. And then c squared equals, what is 64 minus 25? 39. to figure out what any variable equals, don't you have to get it by itself? Why is it currently not by itself? How do you get rid of the squared? Square root it. And so C equals the square root of 39, which you're going to want to put in your calculator and get a decimal version. 6.2. Okay, so that lets us know where to plot the foci. The foci always go on the major axis, which in this case is the x-axis. So I go right 6.2, and there's one of them. And then I go left 6.2, and there's the other one. Now all I have to do is write the coordinates of those 2 points I just plotted. To get to this point, don't you have to go right 6.2 and then 0? And then to get to this one, don't you go left 6.2, so negative 6.2, and then you don't go up or down, so the y value is 0? No, most of the time it won't. Because to get a whole number, you would have to get a perfect square in here, and it just doesn't always work out like that. Yeah, I mean, that's why you want to change it to a decimal, because, like, if you'd have left it square root of 39, would you have known where to plot that on here before you changed it to 6.2? That's why you want to change it to a decimal. Yes, on 2. Okay, the formula for foci is c squared equals a squared minus b squared. Well, we know a is 5, so 5 squared, and we know b is 2, so 2 squared. That becomes 25 minus 4, which becomes 21. Now to get c by itself, we need to get rid of that 2, and how do you get rid of that 2? Square root it. And so c equals the square root of 21, which is what? We'll round it to 4.6. Isn't it 4.5 something? Okay? Now, keep in mind that this time, well, no, because your foci always go on your major axis. So it'll go on the y-axis this time. So 4.6 and negative 4.6. So now all you have to do is write the coordinates of those points. To get to this point, you go nowhere on the x-axis, so 0. But then you go up 4.6 on the y. To get to this focus point, you go nowhere on the x, so the x value is 0, but you go down 4.6 on the y. The focus, or foci, is just the distance from the center, and they're equal distance on each side of the major axis. Yep. Well, and honestly, I guess sometimes you might not have a negative version of it depending on how far the ellipse has been moved off the origin. But we'll look into that tomorrow. Today, let's just focus on when the ellipse is centered at the origin. Okay, turn to page 18 now. No, I don't think y'all are ready quite yet. Let's go. Yes. Okay, here we go. It says, for each graph, write the equation of the ellipse and state the location of the 2 foci and list the length of the major and the minor axis. So I'm going to do those a little out of order. First, I'm going to find the major and the minor axis and identify their length. Just write what I'm writing. Okay, is this ellipse horizontal or vertical? Horizontal. It's on its side, right? Which makes which axis the major one? X, which would mean the minor is Y. How long is the major axis? 14. You do the total length. So from negative 7 to positive 7 is 14 units. How long is the minor axis? 4. Okay? Now we need to identify the A and the B. What do you know about A and B's relationship? A is always bigger. So let's do the length from the center to the side and the center up. What's the length from the center to the side? 7. What about the center up? So A will be 7 and B will be 2, because A is always the bigger one. So now we're ready to write the equation of this ellipse. Remember, it's always x squared plus y squared equals 1. And then you're just plugging in 7 and 2 up under them and squaring them. You just have to decide which one goes where. Well, under the x should be the 7, right, because 7 is on the x-axis, and you square it and you get 49. Under the y will be the 2, so when you square it, you get 4. So now we've found the major and the minor axis and their lengths. We found A and B and written the equation of the ellipse. Now we need to do the foci, which is c squared equals a, right. So c squared equals, what is a squared going to be? Which is, and then minus, what's b squared going to end up? And so c squared will equal, and then just get c by itself, right? And so c equals the square root of 45, which is 6.7. Okay? And where do we plot the foci? Which axis? Right, the x-axis. And think about it. If you went up 6.7 on the y, you'd be outside of the ellipse. They have to be inside. So it has to be on the x-axis. And they're really close to the edge. And so now we just need to write those two coordinates. What is the coordinates of this focus point? Right. And what is the coordinate of this? Right. Okay, try number 2 and then I'll go over it. Okay, is this a vertical or horizontal ellipse? Vertical. Okay, which makes the major axis the y-axis, and so that would automatically mean the minor is the x. How long is the major axis? How long is the minor? Hey, Anna, did you have a question? I thought you raised your hand.
I did. What's the question?
Okay, so now we need to figure out the A and the B. And we know A has to be the bigger number. So, what is the length from the center to the side of the ellipse? 4 units. What's the length from the center to the top? 6. So that makes A 6 and B 4, correct? So now that we have that, we can write the equation of this ellipse. X squared plus y squared equals 1. Okay, below the x, you need to look at the x-axis number, 4. When you square it, you get 16. And then below the y, we'll look at the number that we put on the y-axis, which was 6. When you square it, you get 36. Wouldn't it be nice if we could stop there and not worry about the foci? Okay, now for the foci. It's c squared equals a squared minus b squared. Okay, that will become c squared equals 36 minus 16, which will become 20. And so when you square root both sides to solve for c, 4.5. Okay, now you obviously can't go 4.5 this way or you'd be outside the ellipse, so that's why your foci always have to be plotted on the major axis. So 4.5 up and 4.5 down, which makes the two coordinates of the foci 0, 4.5 and 0, negative 4.5. I don't know about that. I'll have to look at the test to know exactly how it asks. You probably aren't even going to have to say that at all, but you'll have to recognize it so that you know that this is the major. Yeah, go ahead and try number 3. Because it's on the y-axis this time. Yeah. Yeah, because they're going by 2. Or really they're not, they're just only labeled on the 2 parts. On the 2 lines. Okay, be trying number 3. Number 3. Is this horizontal or vertical? Horizontal. Which means the major axis is the x-axis, and how long is it? 12. The minor axis is the y-axis, and it's 2. And have y'all noticed that each time the A is just half of the major and the B is half of the minor? Yeah. And if you want to, you can write it on there 6 and 1 if it helps you. Okay, so now under the x, we need to put 6 squared, which is 36. And under the y, we put 1 squared, which is 1. So that's the equation of the ellipse. Now we have to do the foci. C squared equals A squared, which will be 36, minus B squared, which will be 1, gives you 35. And so when you square root both sides, you get 5.9. So you have to go 5.9 this way, which is almost at the edge pretty much, and 5.9 this way. And so those coordinates are 5.90, and that looks like a comma, and negative 5.90. Okay, try number 4. Yep. It is. It was even hard for me in college. The problem in college is you're going to have a hard time finding any teacher who teaches like I do. Like the majority of the math teachers in high school do. Yes. What? I know, it's just the same ellipse, it's just been turned vertical. Yeah. Yeah, like they literally will get up there and do 1 or 2 examples, and then they're like, assign your word. And then they don't go over the homework the next day. Yeah, like if you want to go over it, you have to schedule an appointment during their office hours.
Is that extra money?
No, you don't have to pay for that. You just schedule. Now, they do have tutoring. No, I feel like at West Georgia the tutoring was free too. They would just get upper level math students to do it. And I don't know, like, if they got paid somehow, I don't really know. I didn't hardly ever use that tutoring. I would just go to the professor's office and get help. Me and Mr. Backus. Y'all remember Mr. Backus?
Oh,
Oh, really? He was here y'all's freshman year, I guess. But we were in, like, every single math class together in college, and so we would do all our homework together, and we were always in the professor's office together.
I'm gonna find me a study buddy.
You need to.
Yeah. I should get friends from upper class at her college. I don't know what he is.
Now, many people noticed right away that this ellipse is the exact same as this one. It's just been turned vertical. So this time, the major axis is the y-axis, and it's 12 units. And the minor axis is the x-axis, and it's 2 units. So that this time, that would make the A 6 still, because A is always bigger, and the B is 1. However, in the equation, since y is the bigger one, the 6 goes under here and gets squared, the 1 goes under here and gets squared. It's just flip-flop because they turned it to a vertical ellipse. And so the foci is also going to be the same, except for the fact that it's up 5.9 and down 5.9. So when you write your coordinates, it's 0, 5.9, and 0, negative 5.9, because they're on the y-axis this time, so the x coordinates are 0. Okay, your homework assignment, you need to get out your pink sheet, is page 19.